So 5.3 is rational functions. And so rational means just we can write it or represent it as a fraction. Remember that? Okay. That's just a fancy way of saying fraction. And in this section, what we want to do is we want to do two things. We want to find out how to find um, number one, vertical asymptotes. I call that VA. And then we want to find um, horizontal asymptotes. Okay. And actually a third component, and that would be if there's any oblique ones as well. Okay. So oblique asymptotes. All right. So that's a key right there. So let's focus. Well, first of all, let's make sure everybody knows what these are. So remember, vertical asymptotes. Okay. So remember, a vertical asymptote just goes up and down, right? That's a vertical asymptote, and it's represented by x equals a number. So x equals 1 or x equals 2, right? Whatever, right? So it's a vertical. Horizontal asymptote goes um, directly across, right? So like here. So that's represented by y. So like y equals -3 or something, okay? That is a horizontal asymptote. An oblique asymptote is basically um, it's going on a slant way. So in this case, if we have a graph, say coming coming through the origin here, okay, all right. So the um, oblique asymptote is something like it's um, approaching that y equals x, okay, graph, all right. So anyway, so that's what an oblique, I mean, it can also come in this direction as well, you know, right? So it's approaching um, that y equals x, okay? So, but it's sometimes called a slanted graph or asymptote. All right, so first let's figure out vertical asymptote, and it's really simple, okay? Vertical, remember, rational functions, the part with that is always the denominator, right? The denominator is our issue. So So let's do that here. So I want to find the vertical asymptotes. And again, if I have a function, say r of x, right, and it's 1 over x squared minus 4, I just want to focus the denominator, okay? So I just focus on the denominator and I pull that out and I set it equal to 0, all right? So that becomes x squared equals 4 and then solve for x. So that gives us x is equal to plus or minus 2, right? If we take the square root of both sides. Okay. All right. So that will be the vertical asymptotes because that's where it's having issues. It's at +2 and -2. It's making the denominator go crazy or 0. Okay. All right. So let's try another one. So let's say we had say r of x is equal to 2x over x squared minus 8x plus 16. Okay. All right. So again, I don't really care what's happening on the top. All I'm gonna worry about is the denominator. Okay. So let's just focus on the denominator. All right. So again, I pull that out and then I set that equal to 0. Okay. And then I just factor. So when I factor this, we get x minus 4 and then x minus 4. equals 0. So x minus 4 equals 0. It's the same factor, so I don't do it twice. So x gives me 4. All right, so that means that we have a vertical asymptote at x equals 4. All right, so that will be the answer there. Okay, so again, when it's talking about the vertical asymptotes, you just focus on the denominator. Set it to 0 and solve for x. Okay. All right, now the horizontal asymptote is a different ballgame. So I have a chart here. Okay. So this is a summary of finding horizontal or oblique asymptotes. Okay. So you have R of x is equal to P of x over Q of x, which is a rational function. Okay. So don't worry so much about all this notation here. Let's just focus on these steps. All right. So it tells us for the first one, n is less than m. The degree of the numerator is less than the degree of the denominator. Okay. So n, right, is the numerator degree and m is the denominator degree. So it's telling us if n is less than m, then we have a horizontal asymptote at y is equal to 0. That's what that's saying. All right. So for example, if I have y is equal to x squared over x3, okay, so n is equal to 2 and m is equal to 3. So notice that n is less than m because 2 is less than 3. Okay, so in this case then, if we have this scenario, then y is equal to 0 is our answer. That means we have a horizontal asymptote at y is equal to 0. Okay. All right, so that's what that's saying. Now let's look at when n is bigger or equal to m. So let's focus on when n is equal to m. So let's say we have y is equal to 8x to the fourth divided by 2x to the fourth. Okay. So n in the numerator is 4, m is in the numerator is 4. So n is equal to m. So 4 is equal to 4. So when we have that, that means what we can do is we can just simplify by canceling out the x4s. And then we have 8 divided by 2, which is equal to 4. Okay, so that means then we have a horizontal asymptote at y is equal to 4. Okay, the next one says if m is bigger than the degree of numerator is one more than the degree of the denominator, okay, what do we have? We're going to have an oblique asymptote. So, um, so if we have, say, y is equal to x to the fifth divided by um, x to the fourth, okay? So it's one more than the numerator, right? So n is equal to 5, m is equal to 4. So the numerator is one more than the denominator, right? That's just saying just plus 1. So that if we have that scenario, okay, so when n is equal to m plus 1, then if we have that scenario, then we have an oblique asymptote. And it's y equals mx plus b, and we have to do that next time. Or maybe I can squeeze it in here. But anyway, we would have to find that equation, okay? All right, and then the last one here, if n is bigger or equal to m plus 2, so it's 2 or more greater, okay? All right, so then if we had that, we have neither a horizontal nor an oblique asymptote, okay? So for example, if we have y is equal to x6 over x to the fourth, right? N is equal to 6, m is equal to 4, and n is bigger than 4, at least 2 or more, right? So 6 is bigger, 4 plus 2, okay, 2 or more. So in this case, we have no um, no horizontal asymptote and then no oblique asymptote. Okay. All right. So let's try record this. So we're going to look for here the oblique asymptote. Okay, so OA. All right, so we have this R of X is equal to um, 3x to the fourth minus x squared divided by x cubed minus x squared plus 1. So remember, if the numerator is bigger than the denominator in regards to the power by at least 1, then we will have an oblique asymptote. So how do we do that? Well, in order to find oblique asymptote, we need to do long division. Okay? So, so in this case, we'll have x cubed um, minus x squared plus 1. And then we have 3x to the fourth. Now we have several terms missing, so I'm just going to put, you don't have to do this, but I just put placeholders there. So 0x cubed minus x squared plus 0x plus 0. Okay, you don't have to do that. You don't have to put the zeros in there, but it just helps me as I try to figure this out. Okay, so just a real quick here, just a refresher on division, right? So if we have uh, 48 divided by 3, I'll have the 3 in the front and 48 in here, right? So if I do division, I need to multiply 3 by 1. 1 times 3 will give me 3 here. Then I subtract this, gives me 1. And I bring this down, gives me 18. Then I need to find another number multiplied by 3 will give me 18. So that's 6 times 3, which is 18. Subtract gives me remainder 0. Okay? We go through the same process on this one. So what I want to do is I want to find a number or term multiplied to x cubed that matches 3x to the fourth. Okay? So in this case, I need a 3 and an x. So x cubed minus x squared plus 1. Okay? So because 3 times 3x is going to give me 3x to the fourth, right? So if I distribute this, this is going to give me 3x to the fourth minus 3x to the third and then plus 3x. Okay? So, and then I subtract them. Now you have to be careful because you want to subtract the whole thing. So 3x to the fourth minus 3x to the fourth is 0. And then 0 minus a negative is going to give us a positive 3x to the third. Now you know why I put those placeholders there. The minus x squared just drops down. And then this one becomes, because there's a minus here, it becomes a minus 3x. Okay? So we get 3x cubed minus x squared minus 3x. All right? Okay, so now we need to, so again, we have 3x up here. So now we need to focus our efforts on the 3x to the cube. So again, I write down x cubed minus x squared plus 1. And I want to match. I want to match the 3x cubed, all right, with the x cubed here. So that means I need to multiply it by 3. Okay, so 3 here. So when I distribute that, I'm going to get 3x cubed minus 3x squared plus 3. Okay, then I subtract the whole thing. So that gives me 0. And this is a minus minus a positive 3x plus a negative 1x. So that's going to give me a negative 2x squared, a minus 3x, and a positive 3. Okay. Now there's nothing else I can do because now this x3 is bigger than the x squared. So I just leave it like that. But what I want, all right, I did a multiply by 3. What I want is this, this part here that we figured out, the 3x plus 3. Okay, this is going to be the oblique asymptote. So this is going to be y is equal to 3x plus 3. That's what they want. Okay, all the remainder here, because we're going to get a remainder, we don't want any of that. We just want what we had multiplied by, and that will be the oblique asymptote.